Most people treat AI like a glorified search engine. You type a prompt, it goes to the cloud, and you get an answer. But using an external provider for real work comes with a hidden cost. Every query compounds your API expenses. More importantly, the moment you upload sensitive financial documents or private records, your organization loses control of that data to a remote server. There is an alternative. You can run a fully autonomous AI agent entirely on your local hardware. Today, we are going to build an agent that can read through your private document folders and automate your admin work. We will do this following two strict rules. It will require 0 lines of code, and it will cost absolutely nothing. To achieve total data sovereignty, you have to sever the connection to cloud providers entirely. Here is exactly how to do it. Step 1 is understanding the blueprint. We are building a privacy-first system called RAG-Stack. This chart shows the complete architecture. On the left is the document ingestion pipeline, where files are processed. On the right is the retrieval pipeline, where the agent reasons through questions. Notice the top boundary condition. The entire environment is air-gapped with no external APIs. You can run this entire stack on a standard CPU. However, if you utilize an NVIDIA RTX GPU, the system accelerates drastically, cutting response times down to a fraction of a second. This blueprint provides the roadmap for our project. It defines a system where every byte of data stays within the perimeter of your local machine. Every autonomous agent needs a reasoning engine. To keep our data safe, we need one we own rather than one we rent from an external provider. We solve this using a llama. A llama is an application that downloads and executes large language models directly on your personal hardware. You open your terminal and type a single command, a llama run Mistral. That command pulls the model to your machine. You now have a state-of-the-art language model running completely independently of Wi-Fi or network access. Capturing and running the language model locally is your first real step. It forms the base prerequisite for establishing true offline autonomy. The biggest barrier to building a custom AI is the assumption that you need to write complex Python code to connect your databases to the model. We bypass that entirely with LangFlow. LangFlow is an open-source visual interface that replaces manual coding with a drag-and-drop canvas. Instead of writing scripts, you select system components from a menu and place them as physical nodes directly onto your workspace. To dictate how your data flows through the agent, you simply click and draw connecting lines between these visual nodes. Frameworks like this change the building process. Instead of managing syntax and dependencies in a text editor, you're organizing logic on a grid. Now we need to feed the agent our private data. If you try to dump massive, dense PDF folders into an AI all at once, you will hit its memory limit. To ingest the raw files safely, we drag the PyMu-PDF document loader node onto our canvas. Next, we attach a text splitter node. This tool divides your large documents into precise, uniform segments of roughly 300 words each. Once the text is split, we introduce a local embedding model called sentence transformers. This model acts as a translator. It reads those 300-word segments and converts them into numerical data that the AI can quickly search. Strictly chunking and embedding the text ensures the model only sees the most relevant snippets for each query, grounding its answers in your specific data. With our data converted into numbers, we need a high-speed filing system to house those chunks. This diagram outlines our storage solution. We use the FAIS vector index, a high-speed local database optimized for offline semantic search. To finalize the build, we draw our routing line from a face database through the retrieval step directly into the Ollama local model. Because we are snapping together visual nodes, constructing this entire architecture takes only a few minutes on the canvas. This completed visual pipeline represents a functional retrieval system that handles indexing and search entirely on your own hard drive. Let's run a stress test. We load the system with over 1,000 pages of dense compliance and financial policies. Then we pose a complex question that requires the agent to pull information from multiple different documents. Internally, the agent utilizes your local NVIDIA RTX GPU. It rapidly scans the face index for precise semantic matches, executing without touching the internet. The agent generates an answer, correctly synthesizing the cross-document requirements according to the raw source material. To
To establish trust, the agent provides exact citations.
It points you directly to the specific file name and page number where it found the data. Cross-referencing thousands of policy pages would take human analysts weeks of manual labor. Our local agent completes the task in seconds. We've built a system that provides data sovereignty and localized automation without a single API call or data leak. You can download this template below to start managing your own documents today.